Hello everyone, I am Professor Praveen, Assistant Professor, Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology, Yelahanka, Bangalore, will be taking microcontrollers 18EE52 for electrical 5th semester students. I will be teaching module number 1 8051 microcontroller basics. In this module, you will be studying the concepts such as what is inside the computer, definition of a microcontroller, the difference between microcontroller and microprocessors, what do you mean by an embedded processor, the block diagram of 8051, what do you mean by program status word, and what are the flag bits, what is a 8051 register banks, what is a stack, what do you mean by internal memory organization, what are the input output ports used in microcontroller, what are the special function register and their uses in 8051, the pin diagram of 8051, memory addressing decoding, and you will also be studying the different addressing modes in module number 1. So let us first understand the definition of a microcontroller. So a microcontroller is a on-chip programmable digital processor which has all the peripherals inside the inside a chip is called as a microcontroller. Both microcontroller and microprocessors are complex sequential digital circuits which are meant to carry out job according to the program or the instructions. Sometimes it makes the analog and input or output interface a part of microcontroller circuit as a mixed mode. Let us see what are the differences between a microprocessor and a microcontroller. A microprocessor is defined as a off-chip device in which RAM, random access memory, ROM, read-only memory, input-output device, central processing unit are externally connected. Whereas in a microcontroller, it is a on-chip, that is random access memory, read-only memory, input-output devices, processor are internally connected. Microprocessors are usually a general purpose unit, whereas microcontroller are specific purpose unit, which is designed for a specific purpose is called as a microcontroller, which can be used for any purpose is called as a microprocessor. Microprocessors are highly expensive because you need to purchase all the devices external components and connect it to the processor, where they are not that expensive microcontroller because everything is available in a single chip. Coming to the power consumption, microprocessors consume more power because all the external devices require power and each devices may require power, whereas here all the devices are present inside a single chip, therefore low power consumption. Microprocessors are used for high scale application. Microcontrollers are used for low scale application. Microprocessors obey von Neumann architecture. Microcontrollers obey Harvard architecture. Microprocessors have high processing power. Microcontrollers have low processing power. Microprocessors are relatively low in speed. Microcontrollers are relatively high speed. Coming to the accessing time, it requires more time to access memory and input devices in the case of microprocessor, whereas in a microcontroller, the access time for memory and input devices are less. Let us understand what do we mean by an embedded processor. An embedded processor is a software which is inside a hardware is called an embedded processor. An embedded system uses a microprocessor to complete one task. An embedded system can be an independent system or it can be a part of a large system. In a fire alarm circuit, a fire alarm is an embedded system which can sense smoke and which activates the alarm or sprinkler. An embedded system has hardware, application software, and sometimes real-time operating system. A real-time operating system is not mandatory. It may have or it may not have, which supervises the application software. Therefore, we define an embedded system as a microcontroller based, software driven, reliable, real time control system. Let us see the block diagram of 8051 microcontroller. It consists of the CPU. A CPU is a central processing unit in which it performs arithmetic and logical operations. It is connected to the oscillator where it generates frequency. It is connected to the RAM, that is random access memory, which is of 128 bytes, and connected to ROM, which is a 4 kilobytes uh, block. A bus control, which is going to have address bus, data bus, and which controls the various uh, information connected to the CPU. Input output ports, the ports which are connected to the external devices or which are connected to the outside world. There are four ports in 8051 microcontroller such as port 0, port 1, port 2 and port 3. All the ports are addressable ports as well as the data ports. It consists of two timers, timer 0 and timer 1, and serial ports which has transmission end and reception end or receiving end. And it is also having an interrupt control wherein it is going to control the external interrupts. Let us see what do we mean by a Harvard architecture. So a Harvard architecture is a computer architecture with separate storage and signal pathway for both instruction and data. In the case of a Harvard architecture, there is a separate storage area for both program memory and data memory. In the case of von Neumann architecture, it is having a same memory for both program as well as for the data. Coming to the features of 8051 microcontroller, some of the features are it is a on-chip program memory of 4 kilobytes, 128 bytes of on-chip data RAM, that is random access memory. It has four register bank 0, register bank 1, register bank 2 and register bank 3. And it has 128 user defined software flags. It has 8-bit bidirectional data bus, 16-bit unidirectional address bus, 32 general purpose registers which has each of 8-bit, 16-bit timers. There are two 16-bit timers, timer 0 and timer 1, and it has four 8-bit ports, port 0, port 1, port 2 and port 3, and 16-bit program counter and a data pointer. Let us see what do we understand by program status word. A program status word is a 8-bit special register which is going to store the different flags. What do you mean by a flag? When you perform an operation in a microcontroller, there exists what we call as an carry. It stores the carry, it stores an auxiliary carry, it is used for different purposes such as it selects the registers, it stores the overflow, and it also has a parity. So let us see what do you mean by a carry. So program status word is also known as processor status word, which is a 8-bit special register. Let us start from parity. What is a parity? Let me say I have a 8-bit data in an accumulator. An 8-bit data is usually a hexadecimal number. Whenever we are representing a hexadecimal number, a hexadecimal numbers are usually represented by zeros and ones. So, in the accumulator, if there is a data, it is going to check whether there are even number of ones or odd number of ones in the accumulator. If there are even number of ones, then the parity is going to show 0. If there are odd number of ones, the parity is going to show 1. Let us come to the next bit, which is used for future use. Let us go for the next bit, that is called overflow flag. If there is a overflow that is occurring, this flag is going to turn high. Whereas what is register select? Register select, as I told you, we have 4 register banks. To select the register bank, it is we are using register RS0 and RS1. So depending upon whether it is register bank 0, register bank 1, register bank 2 or register bank 3, we are going to choose. When it is RS not is 0 and RS1 is 0, 0 indicates we are selecting 0. So if this is 0 and this bit is also 0, we'll be selecting register bank 0. If RS not is 1 and RS1 is 0, then we are going to call that bank as register bank 1. If RS1 is 1 and RS not is 0, we'll be selecting register bank 2. And finally, when both the register RS1 and RS0 are high, we are going to select register bank 3. Coming to the auxiliary carry, if there is a carry which is carried from the lower significant bit or the least significant bit to the most significant bit, that carry which is carried from the least significant bit to the most significant bit, that carry is called as an auxiliary carry. Whereas if there is a carry between one least significant bit to another least significant bit, then during an operation such as subtraction, addition, multiplication, or during division, when there is a carry that occurs, this flag is going to become high, else it will become 0. So as I told you, there are 4 register banks: register bank 0, register bank 1, register bank 2, and register bank 3. Register bank 0 is represented from 00 to 07. 08 to 0F is represented for register bank 1. 10 to 17 is represented for register bank 2. 18 to 1F is represented for register bank 3. Let us understand what is a stack. A stack is a small area in the microcontroller which is allocated. It is a small area of RAM which is allocated to hold the data temporarily, is what we call it as a stack. A stack is usually the last in, first out. Anything that you feed into the stack last, you will take the data, that data which you have fed last is going to pop out of the stack first, is what you call it as stack. You call it as last in, first out. What do you mean by last in, first out? The data which you have fed the last one is the data which comes out of the stack first, is called last in, first out. Or I can also say first in, last out. The data which you are feeding initially is the data which comes out last, is what you call it as a stack. A stack has what we call it as a stack pointer, which is going to access the register or the data that you are pointing in a stack. A stack pointer is a 8-bit wide and it can take a value from 00 to FF. The stack pointer register contains a value of 07H. Whenever you feed the data into the stack pointer gets incremented all the time. When you take the data out of the stack pointer gets decremented all the time. Let us understand the structure of the internal RAM in 8051 microcontroller. An internal RAM consists of what we call it as the register banks from 00 to 1FH. We have four register banks: bank 0, bank 1, bank 2, and bank 3. From 20H to 2FH, we have a bit addressable memory, which is used for these bits, that is for storing 8-bit data. So from 20H to 2FH, we are going to store that data inside the microcontroller. That is, we are storing 8-bit data. These are called the 20H to 2FH are called as the bit addressable memory, where the user can feed or store the data inside the microcontroller. 8-bit data can be stored. The general purpose memory is from 30H to 7FH. What is general purpose memory? It is also called as scratchpad area, where you can write the program. You usually write the program from 30H till 7FH. So this is with respect to the internal RAM. The lower 128 bytes of internal RAM consists of three parts, that is the register bank, bit addressable area, and general purpose memory, whereas the upper 128 bytes of internal RAM consists of special function register, that is from 80H to FFH. So as I told you, an internal memory is also called as the main memory, which stores a small amount of data which can be easily accessed when the computer is running. Whereas the upper 128 byte of the RAM is allocated only for special function register. So what is the function of the special function register? It controls the operations of 8051 microcontroller. Some of the special function registers are accumulator, program status word, interrupt enable, power control, input output power registers, etc. Let us see what do you mean by input output port usage in 8051 microcontroller. The input output port is a memory address used by the software to communicate with the hardware onto your computer. The microcontroller has four ports such as port 0, port 1, port 2, and port 3. The four ports which are used for both input operation as well as for output operation. The microcontroller is a 40-pin IC. Out of these 40 pins, the 32 pins are set aside only for these ports, and usually each port has 8 pins. Coming to the 8051 microcontroller pin diagram, which I told you just now, it is a 40-pin IC, out of which the first pin to the 8th pin are used for port 1. It's a 8 pin, as I told you. Since it is a 8-bit port, we say port 1 uh, number 0 to number 7, that is pin number 1 to pin number 7 are usually used for pin number 1 to pin number 8 is usually used for port 1. The ninth pin is called the reset pin, which resets the microcontroller after the operation. We have the 10th and the 11th pin, which are used for port 3, that is not only 10th and 11th, from 10th pin to the 17th pin, which are used for port 3. Again, we need an oscillator to generate frequency. So crystal frequency is produced of 11.0591 is produced to generate a frequency. So that frequency is generated with the help of the two pins, that is 18th and 19th pin, and 20th pin and the 40th pins are used to activate the IC. That is 40th pin is connected to the supply VCC and 20th pin is given to the ground. 21st pin to 28th pin is used for port 2. 29th pin is used for which is used for enabling the which is used to enable. Address latch enable is a 30th pin, and we have the other pin which is called the VPP or A bar, whereas port 0 is used from 32nd pin to 39th pin. Let us see what are the different types of special function registers. Some of the special function registers are accumulator, register B, data pointer, interrupt enable, interrupt protocol. There are four ports: port 0, port 1, port 2, port 3, PCON, PSW, SCON, SBUF, SP, that is called stack pointer, TMOD, TCON, and timers. So, what is accumulator? The internal RAM address of the accumulator is E0H. For register B, the address is F0H. We have a data pointer which is pointing to the external memory location. The address of the external memory location is pointed by a data pointer, which is a 16-bit special function register. The first 8-bit is DPH, which is having an internal RAM location of 83H, and DPL, which is having an internal RAM location of 82H. Interrupt enable, which enables the interrupt pin. The memory location, internal RAM memory location is A8H. Interrupt priority, which sets the priority between the devices that you are connecting. The internal RAM of it is B8H. There are four ports, port 0 to port 3, which has memory location 80H, 90H, A0H, and B0H. Power control is the 87H. PSW is program status word, which is D0H. SCON is called serial port control, which is 98H. Serial port data buffer is 99H. Stack pointer is 81H. Timer mode control is 89H. And timer or counter control is 88H. We have two timers, timer 0 and timer 1. For timer 0, it is 8AH for the lower byte and 8CH for the upper byte. For timer 1, for the lower byte, it is 8BH, and higher byte, it is 8TH. So what do you mean by memory address decoding? The CPU provides the address of the data desired, but the job of the decoding is to locate the selected memory block. You have to select which memory I have to choose. So you have what we call it as a chip select. The chip select must be activated for the memory contents to be accessed. So an address decoder is a binary decoder that has two or more inputs for address bit and one or more output for device selection signals. When the address of a particular device appears on the address inputs, the decoder asserts the selected output for that device. Coming to the last topic, we have addressing modes. What are the different addressing modes in 8051 microcontroller? An addressing mode is representing a data or locating a target data is called as an operand, and addressing that operand is called an addressing mode. In microcontroller family, there are 8 types of addressing mode, such as immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, indexed addressing mode, implied addressing mode. Let us see what is immediate addressing mode. In this immediate addressing mode, the data is provided in the instruction itself. If I have a data, if I want to move the data immediately into a register, that data is specified in the same instruction itself. The data is immediately provided after the opcode. So in this particular instruction, I am moving data 45H into the register R3 directly. So it is called immediate addressing mode. So in the immediate addressing mode, hash indicates that it is a data. Without hash indicates that it is a address. Coming to register addressing mode, in this addressing mode, the source or the destination data should be present in a register. So here you represent the instruction only with the help of the registers. When I say move A comma R5, nowhere I'm mentioning what is the data that is present in register R5. This instruction directly moves the data present in register R5 to the accumulator. What is direct addressing mode? In the direct addressing mode, the source or the destination address it is specified by using a 8-bit data inside the instruction, and this particular addressing mode can only be used for internal memory, not for an external memory. So if I want to move a data from a particular internal data memory location into a register, I will use direct addressing mode. So the data present in 45H data is not 45H. The internal data memory is 45H. It is a memory location inside the microcontroller 45H. When you go to 45H memory location, there will be some data inside it which you are moving it into register R2. Coming to the next one, which is called register indirect addressing mode. So directly you will not be telling which register or which memory location. A register will be having the address of a particular internal memory location. You specify that in register indirect addressing mode. So here I cannot use any other registers other than R0 and R1. So only R0 and R1 are used here for accessing the data. And in the case of 16-bit address, DPTR is used. No other registers can be used. When I say move at the rate of R1, 80H, it indicates that the data that is present in 80H should be moved to the memory location where in register R1 if you go, it would be specifying some address. Into that I'm supposed to move it. Is what you call it as register indirect addressing mode. Indexed addressing mode is nothing but a source memory can only be accessed from the program memory. The destination address is always referred to accumulator. So what does this instruction do? If a program counter is pointing towards a memory location 8000 and if accumulator has data 5, what does this instruction do? 8000 plus 5 is 8005. It goes to the memory location 8005. Whatever data is present in 8005 will be moved to accumulator. This is called indexed addressing mode. Implied addressing mode, in which you are going to operate with a single operand. That is, either you swap the instruction. I'm using a single operand over here. I am not using multiple operands. I'll be using only specific registers. Let me say I have an accumulator data called 90. If I want the lower least significant bit to become most significant bit and most significant bit to become least significant bit, I use this instruction called swap. So this is with respect to the addressing modes in 8051 microcontroller. Thank you for patiently listening to the module number 1. So let us see next module number 2 in the next video. Thank you all of you.